Hello, everyone, and welcome to this Telit webinar, How IIoT Can Optimize Production and Leverage Financial Results. I'm Amanda Flink, Head of Global Events here at Telit, and I will be your moderator for today's event. Before we start, we'd like to gauge an idea of your familiarity with the flexible factory floor and the industrial IoT. If you could, please take a second to fill out our poll question, which you should see on your screen now. Now let's get to know our speakers. To explain this topic today, I am pleased to be joined by two speakers. First, we have Ricardo Buranello, Head of the Platform's Business Unit at Telit. Second, we have David Wang, Founder and CEO at Beat. Just before I hand it over to Ricardo to start the presentation, I have a few quick reminders for our audience. I would like to encourage you to interact by posting questions. We will have time to answer some of those at the end of the presentation. Simply submit a question by posting in the box to the right of the slides. Also, be sure to check out the resources section in the upper right-hand corner of your screen for additional information. Finally, we will send out the presentation slides and replay links to all attendees at the conclusion of this webinar. And with that, Ricardo, I will hand it to you.
Hello, Amanda. Thank you so much, and good morning, everyone. It's a pleasure to be here. Let me start by introducing myself. My name is Ricardo Buranello, and I'm the head of Telit IoT Platforms. It's a pleasure to talk to you. And I would start by saying that one of the most exciting things about my job is the fact that I can work with some of the biggest companies in the world as customers of Telit and some of the most innovative partners that are really reinventing the way that things are being produced out there. And having Beat and David Wang sharing this webinar with me, it's a pleasure. I had the chance to work with Beat for the last couple of years as a Telit partner, and I am beyond impressed with what Beat is delivering for this market. So, David, thank you so much for joining us today.
Yeah, thank you very much for inviting me.
So let me start here by a quick introduction about who Telit is and how we got to this point of industrial IoT. Telit's a global company. We are traded in London Stock Exchange. We are one of the biggest pure IIoT companies in the world. And we have three business divisions. We have the business division for the IoT modules, and then think Telit almost as the Intel of Internet of Things. We produce chips, modules for different technologies, cellular and non-cellular technologies that goes inside different things, from connected cars to smart meters to industrial gateways. Other than this, we have our connectivity division, and we are a global MVNO, and we provide SIM cards, data plans, and software for cellular connectivity. And we have the division that I'm responsible for, that is our software and platform division. Historically, this division came specifically from one acquisition from a spin-off of IBM. And in 2013, Telit acquired this spin-off called ILS Technology. And then we bring to our product portfolio Devicewise and SecureWise, our software and platform solutions for IIoT. Specifically talking about Devicewise, it's impressive how much we could grow during the last couple of years. Just in the last 3 years, we grew more than 105%. And Devicewise is spreading in all the different industries, from automotive to pharmaceutical, heavy machinery, food and beverage, and so much more. This slide I put here just for you guys to understand the magnitude of the presence of Devicewise in the industry. And I decided to take automotive as an example, as this is our biggest vertical at this point. Today, Devicewise is present in 7 out of the 10 biggest car makers in the world. We are inside 10 out of the 20 biggest tier 1 automotive companies in the world. So we are really growing this, and the reason is how easy it becomes for you to deploy industrial IoT by using Devicewise as your platform. So talking a little bit about Devicewise. Devicewise is a software. This software basically can be installed in any type of equipment of OS that you have on your shop floor. Devicewise can run in a Windows or Linux server. It can run on cellular gateways. It can run on big mainframes such as IBM AIX platform. It can run in small Raspberry Pis. It can basically run anywhere. When you have this software installed, you have hundreds of drivers available for you basically to collect data in real time from all sorts of equipment that you have, from PLCs to robots, sensors, RFID readers, barcode readers, CNCs, and torque tools, and any sort of physical equipment that you have on your shop floor. When you have all Devicewise collecting data from these devices, all the tag tree gets auto-enumerated. So the data is available for you to collect and transform this data in real time. You can also integrate this data to different types of platforms and IT components, such as databases, SQL, Oracle, any type of database, enterprise systems, SAP, ERPs, Oracle, MES systems like Siemens Sematic IT or the SOA Priso or so much more. Devicewise also has a data visualization tool that you can have your visualization. You can transform your data in KPIs and see in charts. And for you to create your HMIs or your dashboards, it's as easy as building a PowerPoint. You just drag and drop the charts, the widgets that you want, and you link this to the variables in Devicewise. So you really can have applications for you to control the efficiency of your line in a few minutes. And we have all our cloud connectors, so we can also collect data, push data on a completely bidirectional way to any type of cloud solutions like Amazon AWS, Microsoft Azure, PTC ThinkWorks, Siemens MindSphere, and so on and so forth. So what can you do with Devicewise? The solutions are endless. By being a platform, you can create your applications on top of that. You can do integration and automation out of Devicewise. You can make a Siemens controller to talk to a Mitsubishi controller, a Fennec robot. So all the devices, they become interconnectable between them. You can create preventive and predictive maintenance solutions by collecting the data, understanding the data of your machines, and making sure that you are preventing downtime on failures of your devices. You can have online real-time quality control, making sure that you have zero defect coming out of your line. You can collect the data, transform the data, and create KPIs such as OEE and have this visualization, all these done in real time. And you can have the complete integration between your IT and OT components in a completely bidirectional way. If you, for example, is running your MES system, Devicewise can read the data coming from your MES system and, for example, understanding what is the next part number to be produced. At this point, as I know what is the next part number to be produced, I can go to a database, collect a recipe for my controllers, and set up the controller to produce this next part number based on what your MES is telling you. I can collect the data and understand how is the setup of the line and just allow my line to start working if my controller, my MES system, and all my tooling is in line and properly set. And I can have all these AI, the artificial intelligence, the cognitive platforms, the data analytics completely integrated on your machines. So I can push the data from your controller to this data analytics, run the algorithms on the data analytics, understand how the line can be improved, and apply the changes in the machines, all these with zero human interactions. The most exciting thing is that Devicewise is a no-code, low-code type of platform. So all the development that you do, you don't need to write one single line of code. You just do the setup with drag and drop blocks of logics. You define when your triggers are running, and then you can have this real-time integration with no code needed, significantly reducing the complexity and the cost for your IoT deployment. But at the end of the day, what is an IoT factory? I decided to take this picture here, and this is certainly not an IoT factory, right? Just look like any other factory out there. And now, let me show an IoT factory. This is an IoT factory. Basically, this is the same factory. What does make this an IoT? Is it the AWS platform that this customer is using? I don't think so, not by itself. Is it this Rockwell controller that you have on the smart crane? Certainly not. Every factory has controllers from Rockwell or Siemens and so on and so forth. Like the Siemens controller that I have here, maybe a Siemens CNC over there, maybe an AGV moving parts by itself across the line, maybe the robot that I have on this right side of my picture, maybe the people that are operating, or my ERP from SAP, my Oracle databases, and my HMIs and dashboards, is still these components by itself doesn't transform this factory in an IoT factory. What makes this factory to really gain productivity and to really is the intercommunication that we can create among all these pieces. And this is exactly what Devicewise does. So on an expanded scenario here, Devicewise, as I explained, it is a software that can be installed on premises in any sort of machine, of server, of IPC, and you can have this bidirectional communication and integration between machines and IT systems. You can not only collect the data, but transform this data and integrate this data. You can also build visualizations there. But also, we like to think about two types of industrial IoT deployments. Deployments that happens completely on premises inside the four walls, or deployments that also needs to go to the cloud because of the distance, because of the fact that devices are not always at the same network. So for example, if you are a machine builder and you are building machines that will be deployed everywhere, like one very simple example, a car wash machine. This car wash machine can be deployed in many different places. You can use Devicewise running on cellular gateway, collecting the data from these machines that are completely remote, aggregating this data, pushing this data to the cloud, having data visualization of these devices, as well as opening tunnels for you not only to see the results of the process of your machine, but also having access to your machine without the need of jumping into an airplane. So this provides the full picture of Devicewise, both for use cases that will be completely deployed on premises locally, or projects that will be deployed geographically distributed, and we have the solution for these both scenarios. The way that Telit goes to the market is also through partnerships, and now I will pass the ball to David Wang. David Wang is the CEO of Beat, and Beat is a strong partner of Telit. Beat developed one product called Envision that uses Devicewise as a core component of this solution. And it's really great to have you here, David. So I'm passing the ball to you.
Yeah, thank you, Ricardo. So I just want to give everyone a quick background where we come from. Okay, I'm the founder and CEO of Beat, where we have been in business since 2011. My career started as a control engineer, basically working in a system integrator, doing large welding assembly lines as a control. in controls, and during the early stage of ERP implementation, I moved into IT to help representing engineering to do ERP implementation, raise through the ranks in IT, become the CIO for North America, and working IT for more than 10 years, moved back to business, was the head of controls for the previous company, and eventually was the global vice president for engineering for their body welding business unit. And so my background really spans controls, IT, and the overall process. So that's kind of our where we come from. So what you see here is actually a concept 12 years in the making. And I will jump into this. We call this Envision Process Visibility Systems. Okay. So before I jump right into technology, I know everyone, probably a lot of people online here are technology people. I want to share a little bit of what we have learned in the last 9 years. When we come out, Industry 4.0 is not something that everyone talk about, and we really had a hard time to gain attraction in the marketplace. The last 4 years, everyone is talking about Industry 4.0. We have learned a little bit lesson, and I would like to share some of them with you. Okay. So the first part really is try to understand Industry 4.0 and the future of manufacturing. During the last several years, right, everywhere we go, we realize there's really a manufacturing reality and a manufacturing dream. The reality in the factory floor, if you work in the factory floor every day, it's a firefighting environment. You have unplanned downtimes. You have issues with production rate, and you have to use overtime to make the same amount of parts you plan to do in 8 hours. You might have to use 12 hours. So it is crisis after crisis. On the other hand, a lot of companies today is chasing these dreams of Industry 4.0, smart factories, all this stuff. And the dilemma lies in the people who are in charge of deliver day-to-day production goals are the same guys tasked with building this future, and they are really stressed out. Okay, a lot of times if you go to the factory floor, you want to talk with these guys about Industry 4.0. They want to kind of strangle you because they said, hey, I have all these problems. Don't tell me about the streams, right? Our goal is to help these people, to help these people who are stressed out, who are the workers, who are the plant managers who have to deliver day-to-day production results. Meanwhile, they had to build a foundation for the future. So how can you do that, right? The other thing I think, I don't know how many people online here ever really think about why we're doing Industry 4.0. Is this something just, it's hot air, it's going to, the balloon will be popped very soon? Actually, it's not, right? I mean, if you realize the people you're hiring into the company today, they are probably all born after 1980s. And these people grown in the internet age, right? They're different. They like to deal their work through smart devices. So to leverage these people's skill sets and the environment they're comfortable with, you force every company to go through this process digitization and workflow visualization. It's something you must do. If you don't do it, you won't be survive. You won't be able to keep the newer generation workers to be able to work in the environment they're not familiar with. Okay, so this is, I think, the fundamental drives in this Industry 4.0. The other thing we heard a lot about is data. Okay, everyone think about the data. There's a lot of data today, but I'll tell you, there's more data coming. Especially, like what Telit is doing. They're piping to more of the lines. The more data is coming. It's like the tsunami, right? But I want everyone, if you walk away from this seminar, when you take this journey of Industry 4.0, when you deal with data, you need to remember some of these three basic things, right? The first two things I think everyone can really relate to. Data doesn't equal to value, okay? And bad data is garbage. I think everyone can understand that. But the next thing is a lot of people don't realize is if you collect a lot of data, you don't use them, they become garbage very quickly, okay? So if you collect data, if you don't convert them to something useful, it won't create value. And so you have to keep that in mind as you undertake this journey in Industry 4.0. The next thing I think everyone heard a lot about is analytics, right? I always want to ask people, what is truly is analytics? Okay, can analytics alone achieve Industry 4.0? through our journey, right, we really understand analytics is really a process. The data is like the iron ore, right? You have raw, you have a filter. The analytic process is really the distilling process. You know, make the iron and steel, in this case, the information. And then once you have the iron and steel, you can make a lot of usage out of it. So analytics, by the end, is facilitate data reduction to actionable information. And analytics alone is not Industry 4.0. So you have to, you know, when you engage companies that they come in just dealing with analytics, there's not enough, okay? What you need to have is really, you need to have data, you need to have analytics, and you need to use software to bind together to create a platform for the future. So my final slide I want to share with you is what's the value for Industry 4.0, as what's this journey look like from today's reality to tomorrow's future? And it's really, for us, it's not something you find the software, you implement, you're done. It's a really a long journey. It's a step-by-step journey, right? The first thing we talk about is what's the new value chain, right? The data and information is really first two blocks. Then you need to transform that into knowledge and generate new intelligence, ultimately to create new decisions. Okay, this is the new value chain for Industry 4.0. The next one, actually, a lot of time, for me, this is the most important thing is, as a new revolution starts, people talk about data modeling, analytics, right? But what's truly important is really you need to generate a different user experience and ultimately create different user behavior. That's when the revolution takes hold, okay? A lot of companies today, you know, will talk about their analytic company, they do data models and all this stuff. But ultimately, you need to transform is user experience. I want to just compare this transformation to everyone's digital transformation. You know, everyone, I think, online, you use a smartphone, right? The iPhone. And 12 years ago, when Apple came with iPhone, a lot of people laugh at them, right? But today, when you look at your smartphone in your hand, what is that? What is that phone? That phone is not just a phone anymore. It's a connection between you and all the data and knowledge humanity have accumulated. It's a different way of you to connect with anybody who owns another smartphone in the world, right? It's a connection. What's enabled that to become that device is the user experience iPhone created that transformed the world, transform how you access data, how you access knowledge, how you access other people. That user experience create a user behavior today that if you leave the house without your smartphone, you'll feel part of you is missing, right? You would probably not know how to get to somewhere anymore. So the focus of our company working with Telit together is really create a unique user experience on the factory floor, ultimately create a different user behavior. That's when the revolution taking hold. The next path we really see is, you know, today we use data to predicting failures. Tomorrow, what we want to do is really use the data to recommending actions. Ultimately, you want to create a self-healing manufacturing process over the entire factory floor. The last one, which is important, is to serve in this manufacturing business, you need to have domain knowledge. And you need to have industrial partnership like our partnership with Telit. You know, they are very good at connecting to all the devices in the factory floor, you know, connecting the OT with ITs. And then we leverage that expertise. Our cloud partner is Google. And ultimately, what you want to create is culture change in your factory floor. That's when the revolution really bear fruit and take roots, right? So our journey, our interpretation of this journey from the lower left-hand side to the upper right-hand side is a multi-path journey, and it starts from data and end in a new culture. So that's what we see, and hopefully through this this conversation, you'll reach out to us and want us to be a partner with you to go through this journey together. So that's kind of some of the lessons we learn or we distill from our 9-year journey in this Industry 4.0 revolution. And now I want to jump into explaining who we are. Because my background in automation, in large scale welding assembly lines and all this, right? You look at this, you know, humanity history. We start Stone Age to Iron Age, really to the birthplace of a modern production line is Detroit, right? In 1908, Henry Ford came out with Model T, forced the revolution in production line factory floor. And 2020 now, 112 years later, you look at the production line, really nothing really changed. The change is you don't have people anymore. You have machines and robots, right? Today, we live in a society that's fundamentally supported by all the automation system around us, right? I'm going to ask a question to everyone. Have you ever think about what's our relationship with the machines and the automations around us, right? That relationship is actually pretty adversary, right? If we're together in a room, I always ask people, when's the last time you thanked your vehicle, take from place A to place B, okay? When's the last time in your factory you thank a robot performing flawlessly a whole day, right? We only pay attention to machines when they break down, right? We only do something when a clamp will not close, when the tip is broken, right? That's how our relationship is. We never pay attention to a machine when they perform okay. We only pay attention to when they break down. So for us, for Beat, why we want to create Beat is really fundamentally change this relationship to better connect humanity with machine and system. I believe that's also the goal of this Industry 4.0 revolution. So how do we do this? How can we change our relationships between operators or people with machine and system on the factory floor? So one of the things before I jump to the next slide, exactly how we do it is we want to, I don't know how many people ever think about defining manufacturing process. This is how we define manufacturing process. It's motion events that bring functions and pieces to meet precise in space while apply function to pieces. Okay, why it's important for us to understand manufacturing process? Because if you want to digitize something, you want to fundamentally be able to explain what you try to digitize. So if the manufacturing process is a picture, the motion events are pixels. Use one example, right? If a person, operator, going to move a part from a bin to a nest, that motion can be done by a robot, can be done by a slide, maybe can be done by a smart drive. Why you want to put that in the nest? You want to bring a function, a welding, a bending, riveting. You are trying to always, in any manufacturing process, is try to have a material and function to meet in space. And all these enable of the motion and events. And so we want to do is really digitize the manufacturing process down to every motion and events. So if you look at today, Ricardo showed you a lot of systems, ERP systems, the inventory systems, MES systems. All these give you is a pinhole view of the overall manufacturing process. What we want to do is through our technology built on top of the Devicewise is be able to show you the complete down to every single motion event what your factory is doing right now. Okay, so you'll ask, how are we doing it, right? So to compare our technology to something that everyone can relate to is everyone probably know EKG technology, right? Heartbeat. If I want you to show anyone heartbeat, it's kind of hard to do, right? But everyone has a heartbeat. EKG technology was developed to digitize, to visualize heartbeat, something that's really invisible, intangible. To make it visible, you can compare heartbeat to heartbeat. So use that, you can detect potential heart attacks, right? What you see here on the right-hand side is a CNC machine. It's on the left-hand side here, you can see the incoming buffer making connecting rod, okay? Behind the fence is a robot. This big center frame here is a two-side trunnion. It's a vertical turntable. On the front side, the robot load unload, and if you see on the back, there's a little machine with a window. That's a CNC machine, the machining doing the back. And this is the heartbeat of this machine right here. I'm going to enlarge that and show you exactly what that heartbeat looks like. Okay, so I'm going to explain what you're looking at right now. On the horizontal axis, these are the steps this process, will do in one cycle in 35.2 seconds. The first one, W unlock, is like trunnion unlock, trunnion rotate, reset communications, and trunnion lock, and all the steps, right? The vertical axis is how long it actually takes in seconds to complete that step. The blue line is what we call the ideal heartbeat, okay? This tells me how long each step's supposed to take. The bars of green, orange, yellow show me how long actually that step takes, okay? The issue they have with this machine, this is at a time when we're implementing our technology, is a global bottleneck for this OEM. Okay, this is they supposed to make 2 connecting routes every 35.2 seconds. But 18 months after after the launch, when they launched this, it was running at 35.2 at rate. But after 18 months, they were running over 40. And this line supplied 4 final assembly plants. So when they were running 24/7 because of the slowdown of the machine, and they are, whenever they have a shutdown, they have a unplanned downtime, it caused stoppage in the final assembly plant. So we were asked to come in to deal with this project. What happened is traditionally they to speed up the machine, they form a SWAT team with all the departments from the plant, IEs, MEs, the maintenance, and the production people, and also two people, also an engineer from Germany who made the original equipment. Then for 2 weeks, 3 stopwatches, they were able to reduce the cycle time from over 40 to 38.4. And we were asked to help them to try to fix this bottleneck. And we did some offline programming for 1 week. And on Monday, we were able to deploy our technology. On Tuesday, we were able to show them this heartbeat. Okay, I give you kind of 2 examples. Right, first is the W rotate. So when we first showed them the rotation is taking 4 seconds, nobody believed us. Right, they said, well, they asked, anyone change the speed for the rotation? This 20 is several tons. So when you rotate, if you keep the speed, it'll keep rotating until it broke, right? So nobody remember changing anything. So they look at me and say, hey, it's wrong. This cannot rotate 4. I said, we have 3 stopwatches. Let's go to the floor. We time it 4 seconds, 4 seconds. Once faced with reality, when they realize our software was captured the right time, the maintenance guy suddenly remembers, oh, we slowed down the rotation because the gear inside was broken. To keep the production going, they slow the rotation down so they can keep production, and then they forget about it. Okay. So this 2-step here, this 2 robot steps, and they said we just speed up these 2 steps. Okay, and that cannot be this slow. And what happened is the robot was not put back to 100% regular speed; it was still at 75% speed. If you program a robot, you have to slow down the robot. And when you put it back to production, you step the robot speed back, so you make sure the path didn't have any consequences, bad consequences. So the robot was at 75% speed, not 100% speed. So the beauty of our software is when you look at this chart, no matter who you are, even you're a high school kid like my son, if they look at this, they will know exactly how your machine performs. This immediate validation, if you do something, are you positively and negatively impact your cycle time? And so we have 2 patented interface to help you to connect your machine better. So this is a body side, a station in the body side line. Okay, if you look at this on the top, we call it heartbeat view. On the bottom, those little bars representing the last 100 cycles we have collected. The blue line is the design cycle time or the takt time. The white line highlights the cycle I want to show on the top. And if you look at it again, the blue outline is the ideal heartbeat, and the white bracket is the tolerance. And you can see in this case, this step here is exceeding the white bracket; it's become orange. The bottom is exactly the same cycle. What we show you is in the actual sequence of operation views. Okay, here what you can visualize is gaps in your process. In this case, if you look at it, the robot actually is wasting 2 seconds to go to pumps, to go to its routine. Okay, so here we can help to visualize, process gaps that you do not know is there, and those for us is called production leakages. So I want to share with you a case study, actual case study, so you can see how our application at work. Okay. So this is a machining line. Okay. It's a block line. It's a very massive block line, and they are having issues with throughput with this line. Okay. And we installed in the final finished portion of the line, and this is basically a layout of the system. And what they have, like in a normal machining line, is they have two machines because of the cycle time required. Two machines doing the same thing. They do a parallel process. In this case, it's called Op 180A and Op 180B. Both machines doing identical functionalities because of cycle time requirement. What you see here is very quickly, you can do a visually compare one machine to the other. You can obviously see Op 180A perform much better than Op 180B, okay? So this is one of the things we can do. When you implement this with identical machines, we can help you to quickly identify the differences in the performance of both machines and down to every single motion device level. So when we see this, right, we can get into more details, actually show you exactly how both machines work. You can see this is the 180B. We see 180B, how this is a honing operation. And when you see the details, it's doing left-hand honing, right-hand honing, and we can see exactly which side is taking longer, which normally both sides really literally do exactly the same length of machining, honing in this case. It should be identical. And once we were able to point out these differences, they were able to modify, to optimize, and very quickly you can see the before and after. And all the things becomes very, very easy to identify where to make improvement and the impact on the improvement. Once you make the improvement, the next cycle you run, you can immediately validate if the improvement really bears result or not. And this is another feature we have. We can stack up the right hand, the 180A versus 180B. And you can see the before and after how drastically changes in the cycle time based on the area we point out they can make improvement. So ultimately, what this provides to them is a 3 JPH improvement. It's a 25% cycle time reduction. That's huge. In manufacturing, if you can provide 5% improvement in throughput, that's huge. In this case, we provide 25% cycle time reductions. So this is basically how Beat do it, right? Through the technology provided by Devicewise, and we were able to digitize and visualize every device motion event for you and help you to, like the smartphone, connect you to data and knowledge and people better. We connect you to machine like never before. So what does we address? Okay. So we are Beat. We create a system called Envision Process Visibility Systems, and we try to really answer 3 questions for you. Okay, what's wrong now? What might go wrong? And where's the hidden capacity? I know a lot of people can do the first one. Really, you probably have a factory information system already, and you will know exactly what's wrong now. But the other 2, it's really, in a way, has been a holy grail for manufacturing for the last probably 30 years. What might go wrong and where's the hidden capacity? As you can see through the example and the case study we show you, we can really detail down to every motion, every second, how you spend your cycle time and where you can find the optimization. Okay. So to close my presentation or introduction of Beat, right, and I like to use this golden circle to explain Beat. So why we're in here, right? Why we create our business, really to fundamentally change the relationship between automation system with humanity. Basically change the relationship on your factory floor, your operator, your line supervisor, your area manager, your production supervisor, all how they relate, how they link, how they understand the machines and systems. That's what we want to do, right? How we do it is digitize, visualize every device motion events. And what do we produce is this tool, this platform called ePVS, really is try to change how you people understand, interact, and use and manage your automation systems. It's really create a new culture. So we believe what we have created, because we digitize down to every single motion event, will be the foundation for this Industry 4.0. Without doing it, you really cannot go anywhere. So I want to, what's our vision, right? What is our vision of Beat? And in a way, why we name ourselves Beat is, everyone understands Apple, right? Apple is a revolutionary company. What they did is really revolutionize like I said before, the relationship between humanity with data, knowledge, and the people. Okay, really it changed how we interact with the world, how we integrate with the world. So Beat, on the other hand, so Apple is commercial product, consumer product. Beat is in the industrial world. We're root. Nobody really recognizes manufacturing, the importance of manufacturing. So we are underground. We are Beat, and we really want to help you to change your relationship between your machine and systems. And we really want to change how you does manufacturing, and through our technology platform, create a brand new smart factory in your shop floor. So come back to this, right? Bridge the dream to reality, right? So what we do really through our data collection analytics, we create instantaneous value for you, okay? And we everywhere we go, when we do a pilot, we guarantee you we're going to improve your OEE by 5%, okay? Normally 15% throughput improvement and 50% reduction in unplanned downtimes. On the other hand, right, we help you to build this foundation for the future, digitize, visualize every device, right? With that, you can start moving through this, this step by step from data to information to build new knowledge and intelligence to really make different decisions. So, and we believe Beat is the only company in the marketplace can provide instantaneous value right now, and at the same time build a foundation for you to the future. And with that, I'm done with my part of the presentation. I'll turn it back to Amanda.
Yeah, thanks, David, and thanks, Ricardo. Great information here. Before we get to the questions, I am going to drop one last poll to our audience. If you'd like to have one of our experts contact you, please respond here on the poll that you see on your screen, and we'll have someone reach out to you. We do have time for a few questions now, and there is still time to ask a question. So if you would like to, please submit using the box to the right of the slide presentation, and we will do our best to cover it here. So we've gotten a couple here. First question, looks like this might be for David, but what is the typical implementation cycle time for device level monitoring?
Well, normally it really depends on the size of, normally when we go approach a new customer, we will ask them to identify a bottleneck area where they have a lot of problems. Because when we do something, we want to really provide instantaneous benefit for them. A typical, we would like to do an entire system. We use a term called smart tags. Really, it's a data container. How many points we need you to digitize the process? A normal process, depending on the complexity of the systems, once you give us the go-ahead, it normally takes us 2 to 4 weeks to be on site to deploy our technology. It takes anywhere from 1 to 2 weeks to validate, to debug. So in about 4 to 6 weeks, you will be able to see the production running live, and we start to help you to find opportunities and to be able to improve your line. One thing I really want to emphasize, right? I mean, to be able to achieve predictive, we normally tell our customers it's a 3-step process. You can never jump through it. First step we do, once we give you device level intelligence, we optimize your process for you. The first, optimize. The second step is stabilize it. Once you have an optimized process down to every motion event, we help you to stabilize it, because any time now you deviate from that, we can warn you, we can alarm you, right? So first is optimize, second is stabilize, then eventually we get to predictive, right? Those are step dance. And if somebody can come in here and just say, hey, I can do predictive, I think they're just completely, they're just lying to you. That's our experience.
Great, thanks, David. Next question I've got here, how does Devicewise handle connecting legacy machines?
That's a very good question, Amanda. Devicewise has hundreds of drivers for you to collect data from the devices. So basically, we use the Ethernet of the plant network to reach out to these devices. So you can just pick one of the drivers and use this to talk to these devices. And you're going to see that basically every device that you have on your shop floor, we already have a driver for. So you can just click, select what is your IP address, and get all the data available for you to transform and to send to different types of systems, databases, to do data visualization or whatever you need to do. On top of that, there are even customers that they have extremely old devices, like CNCs that are 15, 20, 30 years old, and this devices simply refuses to break. And then these are devices, of course, that 30 years ago, nobody was doing a device to be connected at a network, a CNC to be connected at the network. And then we can use hardware adapters, collect electrical signals, digital and analog IOs, and also convert these electrical signals inside Devicewise. So we really have a mantra here that is no machine behind. So even a very old machine, we still can have this machine connected to Devicewise, even if it's not a network connected device.
Great, thanks, Ricardo. And maybe you both can sort of take a stab at this next one here, but how to Beat and Telit Devicewise work together on gathering the data?
David, do you want to take this one first?
Yeah, actually, what we do is we have a data collector we call the EDCA, Envision Data Collector Appliances, and we have a Devicewise driver depending on what type of PLCs. We basically use Devicewise as our edge device, and we deploy everywhere we deploy. We connect through this EDCA to all the PLCs and collect the necessary data we need. And then our device, our EDCA, will transform these data collected into the cloud. So we're completely cloud-based. We use Devicewise as the connector between the shop floor to the cloud, basically. Ricardo, do you want to add anything?
Yeah, no, I think it's very clear, David. The Devicewise is the edge component, so it does the data collection and the data transformation on the edge, and then we can push all this data to this very sophisticated solution that Beat created. And I'm very impressed about some of the numbers that you showed, David, today. I was thinking when you were showing the numbers, an improvement on the efficiency on 20-25% improvement. I remember one very large automotive factory that I visited a couple of years ago, and I was having the conversation with the engineers of these factories, and they were telling me how Devicewise and IoT could help keeping that factory open. It's a huge manufacturing facility producing 1,800 cars a day. And by the deployment of the technology, they could generate 3,000 minutes that at a cost of $30,000 per minute because of the number of cars, that represented $90 million on return on investment, on efficiency gains for this plant. And at the end, this is what is really driving business these days. I think that 15, 20 years ago, many factories, they decided to go to countries with low labor costs to keep productivity. Now I see a completely different wave where companies that will survive to this new wave are the companies that really can be productive, that can be efficient. And I definitely see this on a very clear way, how the BEAT solution can transform data into results for the factories. And this is, at the end, it's good for everybody. It's good for the companies, it's good for the economy, it's even good for the planet by using less resources and building things better. So it's a very exciting time, what we are seeing and how disruptive IoT is being for manufacturing in general.
Great, thanks. And this next question kind of follows that pretty closely. But what has been the most challenging and or rewarding deployment of Devicewise and BEAT EPBS? Sorry.
Well, as the person, really dream about this technology and come up with this 12 years ago and start the company 9 years ago. Really, the biggest challenge really is, shop floor is about as conservative as can be, and the challenge really is we are, mostly in manufacturing environment, people invest in capital equipment. They're used to just buy the equipment and then owns it, right? And we are trying to sell a SaaS software to this kind of buying culture or environment. That's a challenge by itself. And then the culture in the factory floor, it has been, 50, 60 years is people are dealing with firefighting mentality. Now, everyone who work on the factory floor, you probably silence hundreds of alarms. You ignore them. You're inundated with all kinds of alarms. Now you suddenly come up with a software that can tell you what might go wrong. They laugh at you saying, hey, I have all these problems that's out there that is we don't even have time to deal with it. Now you tell me what might go wrong, So those are really, I think the challenge is not in the technology by the end. In any kind of revolution, not in the technology, because it's in the culture, in the people. It's in how people can embrace it, right? The rewarding part also is, in this kind of things you do, any revolutions, you change one person at a time. You change one facility at a time. You change one process at a time. And when we have been receiving some of the people who really, when they see the power of the software or the capability of this, they were able to see the process for the first time, how happy the people on the factory floor are. Okay, and I have seen emails. I have people tell me how, that what we have done changed their lives. Those are really the rewarding part of the whole thing. And it's a lot slower than I like to be, but it's meanwhile, as any great revolutions or great things, it's going to take extraordinary effort, right? I mean, Telit has been a very, very good patient partner with us, and I think in a lot of times we go through the same struggle.
Yeah, and I can add a couple of comments. I think that IoT might be challenging on different ways depending on the project that you are. One of the common challenges that we have is mostly for discrete manufacturing. When you have high frequency machines, you need to handle data on a super fast way. Otherwise, you have the risk of losing data, or you have the risk of having hidden downtime on your machines if you have latency there. So for example, if you need to send a bit to the machine for the machine to start a certain process, if this is taking 1 second or half of a second, this is a hidden downtime that this machine is not producing. And if you're repeating this process hundreds or thousands of times, this might be a very long time that this machine should be producing and it's not producing. So the way that we engineered Devicewise was to be a real-time data collection and data interface with machines. So always our challenge is we must be as fast as possible on the process, because every millisecond counts for a downtime, and for data loss. So this is where Devicewise really shines in the market. When you compare Devicewise with any other type of data extraction, of data collection, Devicewise is at least 10, 20 times faster. I remember one project that we had with the largest electronic manufacturer in the world in China, and they came to us and said, you know, I already tried 3 different solutions to collect data in the production line that is producing here the cartridges for ink printers, but the fact was that those machines were moving on such a frequency, producing so many parts, that every time the PLC was moving, the data was being erasing, and nobody could handle the data on the speed that the data was created. With Devicewise, they couldn't believe how we went there, and in one day, we were collecting 100% of data with no data loss. So latency is always something that every customer should keep in mind when they are deploying IoT, when they are deploying Industry 4.0, because latency matters a lot on the process. The other thing that is also important, and this deviating a little bit of the example that we gave here, that most of the cases, they are on-prem, they are always handling with machines that are on the same network. But when you have connected machines that are distributed around the world, then you also have this challenge of having the device management of hundreds or thousands of machines that are spread around. And this is also a feature that Devicewise is very strong with. And these are challenges that we are always overcoming in order to provide to our customers the best return.
Thanks, guys. It looks like we have time for maybe one more question, and this is a great one. Current economic conditions are improving for manufacturing after months of shutdown with the global pandemic. How could Beat and Devicewise help create ROI for our production process during these times?
You know, I think one of the things that's interesting is through this COVID-19 crisis, I think a lot of companies now realize you can do remote working remotely. And the manufacturing, you know, one of the most important resources are expertise on the line, right? A lot of time you have probably, you know, company, you have 2-3 guys really know this. And with our ability to digitize every process down to every motion events, you really can create a platform that you can remote monitor, provide remote knowledge. You know, you understand the line, you look at the line just like no matter where you are, and you can understand how the line performs, if there's any process in the wrong way, and then your expert can look at it and provide help for you remotely. And this can greatly improve the knowledge sharing or bring the expertise down to everywhere in the world anytime you want, right? And this is going to help you know, people today these days is remote working. We'll promote that to the extent that is available to any manufacturer. The other thing really is, as everyone knows, this a lot of people new work come on the factory floor, and what we do is really lower the threshold of how well you can understand the process. Everyone look at our chart, look at our interface, will understand the machine far better than ever before. So we can have the operators and even the non-technical people understand process like never before. This is also going to help with them to bring them up to speed so they can produce as quick as possible to the max that they can.
Yeah, I completely agree with you, David. I think that I totally see this trend of remote work. And remote work, when you are on a factory environment, means that you'd have a high need of digitization of your line. You need to have real-time feedback of your line on how your line is operating. Otherwise, you always have the risk, given the challenges of having people there in the line, that you will start seeing decrease on your productivity, and technology certainly can help a lot with that. also for you to have remote capabilities for your engineers. So this can significantly reduce downtime and travel time and travel costs when you have IIoT deployments just like that. And a more macro situation that I see in the market is companies, they want to have their production lines working closer to their consumer markets, but this means you must be efficient. Otherwise, you will not survive in this market, and the technology is what will really guarantee efficiency for you, is your ability of understanding the details of how you are producing and optimizing this. This involves technology, and as what you said very well, David, that is, this involves a mindset. This involves thinking the process different, thinking manufacturing different, and the digitization is here. It's not who will adopt, but it's very clear that everybody needs this sort of technology really to survive in the current environment that we have.
Thanks so much, guys. I believe that's all the time we have for today, and we've just come up on the hour. Audience, please be sure to check your inboxes in the coming days for the slides and a replay link. Thanks, Ricardo, David, and all who joined us today.